Alright, so this is how you do homework for computer architect, right? So we have, first here, we have the question asks, one address machine with an accumulator have what values when these instructions are executed? So what happens to a load immediate, a direct and indirect? What happens is add one, so when it has load immediate, when we speak of immediate only calls the address of the data, and so what happens in the AC accumulator, it would have 20 inside of it. And so next question is load direct. Load direct is it takes the value, not the address, takes the value of that place. So it takes the value of 20. So AC would have 40 here, right? So this is value of the address 20. And 1.3 is indirect 20. So what does this mean? 20, well, it means we want to go to the value of 20 first, and then the value of 20 is 40. Now 40 we want to access what the value at address 40. So address 40 is right here. And what value belongs to 40? It is 60. And so the answer is 60. AC would be 60 right here. Next question number 2 is how do we find a branch target address when we are given a sign displacement instruction of negative 31? So what happens here is this value we're given here is the address of an instruction. So whenever an instruction is processed, this is the counter that bumps up, it increases over time, right? As the more instructions executed. And so the question asks what happens when you have a displacement in the instruction. First thing, let's look at this one first. We have a branch instruction of 3 bytes long. So what happens with the instruction we have? This is our one. We have a value of 256028, and we want to add 3 bytes to it because we want to have because we have an instruction that is 3 bytes long. So to add it on top of the previous instructions we would get 56031, okay, as our current address of instructions. All right. Now the question asks what is the target branch. So we look here, we look carefully here. It says in displacement, sign displacement is of the effective address. EA stands for effective address is A plus R. A is the direct address and R is the register address. Okay. And so in order to find this one is R is basically negative 31 and A is 256. This is very easy. You just figure that out like that. The rest you probably can find it, figure out yourself. That's the answer. Question 3 is asking for what is the clock cycle and clock rate. Now we're given a clock cycle and the time it takes for 6 clock cycles to happen. So what we can say is there's 6 clock cycles that takes a time of 0.7 nanoseconds. Okay. Now what happens in how long does it take for 1 clock cycle to happen? So we just basically just do ratio. 1 clock cycle is equal to how much? How much nanoseconds here, right? So you can figure that out. And next one is what is the clock rate? Clock rate is measured in hertz. And so you can think, oh wait a minute, this one is, in order to find frequency at hertz, is 1 over f, right? Or in this case is 1 over t. For the answer we get here, we just throw it in there and figure it out what it is. แล้วก็ the unit มันจะเป็น hertz, right? But the unit here มันจะเป็น kilo, milli, micro, nano. You have to figure that out. I'll give a hint. It's basically milli. If we go backwards, negative 3, negative 6, negative 9. This would be micro and this would be nano. This would be 0. This would be 3. This would be kilos, and this would be mega, right? And this one would be giga, right? So you can figure out which unit you have to use to put in there, right? Number 4 is we're trying to find the fraction of instructions wasted. So we're trying to find a ratio here. A ratio of wasted instructions over all the instructions, all right? Wasted and all the instructions. That's what we're trying to find. So what we have to do here is determine what is the wasting. Wasting is whenever we jump here. It says that we have 100 instructions here, 100 instructions, and we're trying to jump 20% of the time we're trying to jump. And so what happens here is that 20 of the instructions here is a jump, right? It's a jump. Jump has 20 instructions, right? Now, no jump has 80 instructions, right? Because they add up to 100, right? And so what happens here is we're trying to figure out, okay, so how many bytes it takes, all right, for wasting and all? Well, we basically determine it by if we have no jump, we don't waste anything. And so what happens here is one instruction is 7 bytes long, and so we just times it by 7 bytes. And so whatever we get here would be the answer for no jump. And then for jump, when we jump, we have to flush. No, when we have a queue, we're given a queue here, a queue size of 14 bytes. So we're given a queue of 14 bytes, and then we jump. All these 14 bytes will be flushed out. So flushed. Alright, and so what happens here is 14 bytes wasted, and so we did this 20 times, and so what we can figure out is, yes, of course, it wastes 14 bytes. So figure out total amount of jumps wasted. We have that in bytes. Now we're trying to find a ratio. The ratio of wasted ones. Yeah, is basically the jump wasted over all. Okay, all instructions. So what I mean by all, pay attention. It's this and this, jump and no jump. The total amount of jump and no jump together. Okay, you figure that out, you can answer this one. Last question. Yeah, we're learning about pipelining. Okay, pipelining is basically doing multiple things at a time. It's multitasking, no? And the way it works, yeah, multitasking is whenever it's done with one task, it switches to another thing and does the next available thing instantly. And so how it works is we have 7 instructions to perform, right? We can save time by using pipelining. Okay, so I'll draw it out in the we have to draw a diagram, right? And so to draw a diagram, we draw it like this, instructions right here, and then the cycles would be up here. So this is the time, no? Time t, and number it by cycle number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, now in instructions, what happens here is when instruction 1 begins, it has to perform 4 things. You have to perform fi first, da, fo, and then ex. Okay, so start fi. Okay, now as it works on first cycle completes, it moves on to next task. So when it moves on next task is called da, and when it works on da, fi will be free, and so next instruction can come in and do fi for itself here. Okay, now keep in mind when we're working here, we have to watch out for a jump here that happens at third instruction, but we will get to it. So let's go on. Next instruction cycle, third one, da goes to fo, fi becomes da, and then another guy can come in another instruction. Let's come in and do fi right here. Now this is third instruction, so pay attention to third instruction. Okay, third instruction would jump. You have to pay attention. Third instructions would jump when ex is executed. Okay, so we see what happens. Fourth instruction cycle, fo becomes ex here. This one becomes o. This one becomes da, and then we have another one, fourth one, to be fi right here. Next one we move on. Okay, instruction 1 is done, so move on to instruction 2 would be ex here, fo here, and then number 4 would be da. 5 would perform fi as well. We move on to instruction 6. Instruction 6 would activate ex, fo, and da. Now, just now I told third instructions jump, right? Jump occurs when the third instruction is done with ex, and so he be like, wait a minute, I must jump. And so when he jumps, he needs to jump to 15, right? Instruction number 15. So what happens here is he says like, wait a minute, I need to jump, and so everyone here gets flushed. So everyone here is done for, and we jump right onto 15, which is fi in the cycle of 7. Okay, now I want you to finish this diagram. Just finish what's left here, and then that's pretty much it for pipelining.